Hi, I'm Torren Campbell and I am doing my project on surface groundwater interaction at San Pablo Creek, and today I'll be showing a bit of a demonstration of what I do out in the field and a bit of an overview about my project. So before I begin and get out into the field, if you have any questions or comments, please leave them in the comment section below this video and I will be happy to get to them as soon as I can. Before I continue on, I want to talk about some of the goals of this project. First of all, what inspired me to do this project was how we're losing a lot of the snowpack in the Sierra Nevada. And so because of that, I figured that in the future, we're going to need to know about alternative sources of groundwater. And in the Bay Area, the East Bay Plain, where the San Pablo Creek is one of them. And not only do we have to figure out to sustainably manage the aquifer because of the Sustainable Groundwater Management Act that was passed back in 2014, we also have to know how much we can leave behind for the riparian habitats within the creek. So the way we can do that is by being able to characterize the interactions between the surface water of the creek and the groundwater aquifer. To do that by using radon and discharge, we can get an estimate of not only what if there is an interaction between both, but also how much groundwater is contributing to the surface water of the creek. Another thing I wanted to show you is a map of my project area around San Pablo Creek, including all my sampling locations from both the creek and from the available groundwater wells, so as to give you an idea of the area. So with that message, let's get out to the field. So first thing we do is we get our water quality meter. This shows us all the parameters we want to measure in a creek, such as pH, dissolved oxygen, and conductivity. Now how we go about doing that? Simple. So easy, it might as well be criminal. Now this is a turbidity meter. We use this to measure how many sustained solids there are in the creek. So right now, first we do is just take this calibration sample and we calibrate it. And then all we gotta do is spin this on, take this out, put it in, enter, like that. Simple as that. All right, so the next part of this field is probably the most important. We collect the samples, yay! So now we have two samples. We take one for stable isotope analysis and the other for radon analysis. For the stable isotopes, what you gotta do, just simply fill up like that, and we're done with the stable isotopes. Now for the radon in the hand, we gotta do a bit more. Get our hands a bit more dirty. We gotta get this like straight to the bottom of the creek bed, because that's where all the radon is more likely to be. Yeah, and also another thing about this is that we want this to be completely filled up. We don't want any sort of air left inside, because if we do, the radon will potentially escape and we'll lose our radon measurement. Now we get to the part I find is the longest but also the most interesting part of taking water samples from a creek, measuring the discharge of the creek. So what I do is that I take two stakes and place them at either end of the banks of the creek, and attach a rope between them. Then I take a measuring stake, or in some cases a measuring tape, and I measure the width of the stream. And so this one would be roughly, say, about 10 feet. And then what I do is I go and measure the depth at the creek at different intervals. Okay, so for the second part of measuring discharge, well, there you can do it. What I do is use one of two ways. One, you use a flow probe, or if you want to do something quick, and if you're lazy, you just simply get a dry leaf, a measuring stick, a timer, and then what I do, toss the leaf into the creek, measure how long it takes to go by, and there you have it. I almost forgot the one very important thing. Gotta take GPS coordinates. There's our GPS. So if you all want to do this again, here's the location we did it at. Hi, welcome back to the lab. So as you can see here, we got our radon sample connected to our radon analyzer right here. And as you can see, what it's doing right now is it's aerating the sample and getting all the radon that we have collected in here, and it's bubbling out, going through all this dry to get rid of all the water so that there's just pure radon infused air. And it's going into this instrument here where it'll measure it and provide us with results. One of the major things that I'd like to talk about is like what I've kind of learned throughout this whole project. One is mainly getting and learning about how important project planning is. It's because I encountered a number of limitations regarding this project. One being like the lack of available groundwater wells in order to sample. In fact, like those two that I probably just showed you were like the only ones I was able to find, and I was rather lucky to stumble upon them. So it's important to really learn about like the project area you're working with. So that's all kind of time I have right now. So I hope you've enjoyed my demonstration of what we do out in what I've done out in the field and what sort of data I've been able to collect. So I hope you've had a nice time, and please, as again, leave any questions or comments you have in the chat below. See ya!